So we're starting a new unit. We're talking about linear systems, and today we're going to be talking about how to solve these linear systems using a graph or by graphing. So we know that a linear equation is the equation of a line. We talked about that last unit. This line is represented by the equation y equals mx plus b. A linear system is a set of two or more linear equations that work together. So we can see on the graph over on our right, this line and this line are both on the graph and they cross each other. The solution to a linear system is the point of intersection of two or more lines. So for the red line and the black line, we see that they do touch at a specific point, and that would be the point of intersection, which is also called the solution. So the point of intersection and the solution mean the same thing. At the point of intersection, the values of x and y are the same for both equations. So what it's saying is that this point right here is along the red line and it is along the black line. So they're the same values. So our first example, we're going to solve the linear system below. So we have one equation, which is y equals negative 2x minus 5, and the other equation is y is equal to 2 over, that should be 2 over 3x, that didn't show up for some reason, 2 over 3x, 2 over 3x, 2 over 3x, plus 3. So finding the slope and y-intercept for both. So our first equation here, y equals negative 2x minus 5. My slope is negative 2, or my m value is negative 2, and my y-intercept is negative 5. My slope for the second equation of this is 2 over 3. So my slope value is 2 over 3, not 3 over 2. 2 over 3, and my y-intercept is positive 3. Now, using the slope and y-intercept, I'm going to graph both lines. Okay, so I'm going to take my first line and my second line, and I'm going to graph them over here. So my first line is y equals negative 2x minus 5. Let's do that. Let's keep that in blue. Y equals negative 2x minus 5. My y-intercept is negative 5. And my slope is negative 2, or negative 2 over 1. So what that means, let's zoom in, I go down 2 units over 1 unit. So my next point would be here, down 2 over 1. And I would continue this pattern in plotting these points. Technically, again, you only really need 2 points to draw the line. But I decided to draw a little bit more than that. Hopefully these land all there. There, roughly like this. So this is y equals negative 2x minus 5. My second equation, y equals 2 over 3x plus 3. I'm going to do that in red. My y-intercept value is positive 3. So there's my y-intercept at the positive 3. And my slope is 2 over 3. So up 2 over 3. So I go up 2 units over 3 units, 2, 2, 3. I'm looking at a point right about there. So again, I'm going to draw that line down 2 over 3, and 2 over 3. It's going to look something like that. So then this is y equals 2 over 3x plus 3. Okay, so I've graphed both lines. Now I need to identify the point of intersection. So the point of intersection appears to be right here. And if I was to label those coordinates, I would label them as, well, that looks like negative 3 as my x, and positive 1 as my y, right? So we can see how x is negative 3, y is positive 1. So the point of intersection in terms of the coordinates is negative 3 and 1. Our final step to verify your solution by substituting the point of intersection into both of the equations. Again, we have our x value and our y value. All right, so we have an x value, we have a y value, and I'm going to plug them into each equation. So the first equation I have is y equals 2x minus 5. So my y value is 1. My rest of my equation equals negative 2. What's my x value? My x value is negative 3 minus 5. So then I go ahead and perform the math. I end up having 1 is equal to 6 minus 5. 1 equals 1. Therefore, left side equals right side, or they're balanced out. So the one equation is balanced out. I need to do the exact same thing for my second equation, plugging in the x and the y values from my point of intersection into this other equation, just to kind of prove that it's true. So my y value in this case is 1, would be equal to 2 over 3. My x value is negative 3 plus 3. I end up getting 1 is equal to, well, 2 over 3 multiplied by negative 3 just simply gives me negative 2 plus 3. And then 1 is equal to negative 2 plus 3 is 1. Therefore, left side equals right side, or that they're balanced. So we've gone ahead and proven that the solution to this linear system is negative 3 and 1. Let's go for one more example. Solve the linear system below. So we have two lines. We have this line and this line. 2x plus y equals 5. X minus 2y is equal to 10. Okay, so they're not in slope-intercept form, so we would need to write each equation in slope-intercept form first, or into y equals. So in this case, if I was to take that first equation and rearrange it, I end up getting y is equal to negative 2x plus 5. I just simply brought that 2x over, and I isolated y. To rewrite the equation in slope-intercept form for equation number 2, give myself some more space, well, I end up having negative 2y is equal to negative x, brought that positive x over, plus 10. Then I go ahead and isolate for y by dividing it by negative 2. So I end up getting negative 1 over negative 2x plus 10 over negative 2. I end up getting y is equal to, well, negative over negative is a positive, so it's 1 over 2x. This would be minus 5, simply because we have a positive 10 divided by a negative 2. Positive divided by a negative gives me a negative. So I have both equations in slope-intercept form. Now I need to find the slope and y-intercept for both. So my slope for my first line, negative 2. My y-intercept for my first line would be positive 5. My slope for my second line, 1 over 2. And my y-intercept for my second line would be negative 5. I'm going to go ahead and graph these lines now. So my first one I'm going to graph using the slope and y-intercept, graph both lines, and then label both lines. So first one, I'm going to use the slope of negative 2 and the y-intercept of 5, got in blue. So my y-intercept is at 5, right here, and my slope is negative 2, or negative 2 over 1. So down 2, and then over 1 to the right. Down 2, over 1 to the right. I'm kind of following this pattern here. Down 2, over 1 to the right. Something like that. As best I can there. Y equals negative 2x plus 5. Okay. Second line, do color. My slope is 1 over 2. My y-intercept is negative 5. So I'm going to place that negative 5 right here. I know that that's the point. My slope is 1 over 2. Up 1 and then over 2 to the right. Up 1 over 2. Up 1 over 2. Up 1 over 2. And I get the continuous line that looks like this. Y equals 1 over 2x minus 5. So I've labeled both of them, I've put them both on the graph. Now I'm noticing something. From the graph, the point of intersection appears to be, well, I can see that point specifically, that appears to be x is positive 4 and the y is negative 3. So I would write those coordinates as x, different color here, 4 and negative 3. Our final step, simply just to prove that this is in fact true, I know we can visually see it, but sometimes we won't always be able to see it, is going ahead and plugging the point of intersection, or substituting the point of intersection into both equations. So my first equation, I have 2x plus y equals 5. I know my x value is 4, so we have 2 times 4 plus my y value, which would be negative 3, equals 5. I end up getting 8 minus 3 equals 5. 5 equals 5, and the left side equals the right side. If you wish, you could have just taken the equation as we changed it into slope-y-intercept form. As you can see, I took the original equation, but you can simply take the equation as we rearranged it as well. Last, second equation is x minus 2y equals 10. Plugging in my values, my x value is 4 minus 2, and then my y value is negative 3, equals 10. Well, I know that negative 2 times negative 3 gives me a value of 6, so 4 plus 6 equals 10. 10 equals 10. The left side equals the right side. So we've gone ahead and proven this. So the solution to this linear system is in fact 4 and negative 3. So the big takeaways would be you have two lines on the graph, or your two lines that are given. Find the slope and y-intercept for both, and then place them on the graph. And then referring to the graph to visually see our point of intersection, we go ahead and state our point of intersection. And then just to verify, make sure it's 100%, we take the x and the y value from our point of intersection and plug them into both equation 1 and equation 2 of this linear system.